question answer approach. This is teacher level Hakim. Last Friday, I was here and we discussed some questions on weathering. And the question that we discussed was account for the dominance of physical weathering in the same arid areas of East Africa. And we looked at that approach. However, we did not get time to look at another question which is related to weathering. The first one was account for the dominance of physical weathering in the semi-arid areas of East Africa. But this question, which I'm going to discuss today, is account for the dominance of chemical weathering, this time chemical weathering, in the tropical humid areas of East Africa. So let me write it down so that learners account for the dominance account for the dominance of chemical weathering in the tropical humid areas of East Africa. Full stop. That's the question. Account for the dominance of chemical weathering in the tropical humid areas of East Africa. Now, viewers, this question is about chemical weathering. It is true that chemical weathering dominates in tropical humid areas. Now they're asking me, give the reasons why this type of weathering dominates the tropical humid areas. Let me first write for the approach, then we discuss in detail the approach to that and say, shall define chemical weathering. Define chemical weathering. First, two, we are going to identify tropical humid areas of East Africa. Identify tropical humid areas of East Africa. And then we describe the characteristics, brief description of the characteristics of tropical humid areas. Characteristics of tropical humid areas. Then we shall briefly describe the chemical weathering processes. Chemical weathering processes in these areas. And briefly describe the chemical weathering processes in those areas. And lastly, we shall account for, that is, give reasons for the dominance of chemical weathering in the tropical humid areas. Mid area of East Africa. Stop. That is how approach that question. Account for the dominance of chemical weathering in the tropical humid areas of East Africa. We shall define chemical weathering, identify tropical humid areas in East Africa. We shall mention these areas, and we describe the characteristics of these tropical humid areas. And then we shall say that in these tropical humid areas, chemical weathering processes like, that's when we shall briefly describe the chemical weathering processes in these tropical humid areas. And then we shall give the reasons why chemical weathering dominates in these tropical humid areas. That is the approach. Now we are looking at the detailed answer somehow. First, define chemical weathering. And write it here. Definition of chemical weathering. We say it is the decomposition or decay or rotting of rocks or rotting of rocks near or at the earth's surface in situ. Near or at the earth's surface in situ. So we shall first define chemical weathering. This is chemical weathering. Is the decomposition. I have not said the breakdown. Here we have started by defining chemical weathering straight away, not weathering in general or not physical weathering. So we say it is the decomposition or decay or rotting of rocks near or at the earth's surface in situ. This will be made in words. In situ means made in the same position. Okay. Then we shall say, we shall add another point. Chemical weathering, it occurs as a result of heavy rainfall, occurs as a result of heavy rainfall that provides water facts, that provides water acts as a medium of chemical reactions, as a medium of chemical reactions and hot temperatures. What temperatures accelerate the rate of chemical reactions to accelerate the rate of chemical reactions. Full stop. That is it. Okay. We have now defined. Now we are going to identify tropical humid area. We have defined chemical weathering is the decomposition or rotting of rocks near or at the surface in situ. Add a statement that it occurs. Yes. Yeah. I was saying it occurs, that is chemical, as a result of heavy rainfall, and this heavy rainfall is providing water, and which water acts as a medium of chemical reactions, and then hot temperatures accelerate the rate of chemical reactions. So what we mean here, chemical weathering occurs as a result of heavy rainfall that provides water and hot temperatures. Hot temperatures speed up, accelerate the rate of chemical reactions. So we have finished definition. Okay. Now we are going now to look at identify tropical humidity areas. We are looking at this, and we shall say chemical weathering. Chemical weathering. Chemical weathering is dominant in tropical humid areas. Is dominant in tropical humid areas. Tropical humid areas. Which are these tropical humid areas? For example, Lake Victoria. Let's see. Those are tropical humid areas. Right? Areas of Masaka. Let's say Kampala. Okay. We have now identified the areas. Now we are going to add characteristics of these areas. I think we have this, yes, right. Yes. Right. After defining the weathering, chemical weathering decomposition and plotting the blocks here on surface, chemical weathering occurs as a result of rainfall that provides water that occurs a medium of chemical reaction, and hot temperatures that accelerate the rate of chemical reaction. Then we say that chemical weathering is dominates in tropical humid areas around the Victoria Basin, area of Masaka, Kampala, and the coastal area of East Africa. Okay. Now, characteristics. They are characterized by characterizing by these areas are characterized by heavy and reliable rainfall of above 1,250 millimeters. Heavy rainfall above before it started raining.
We can hear you.
You can hear me now. Okay. before it started raining, we were looking at that question, and you had said you define chemical weathering, which we did. Then from there, identify tropical humid areas, which we did, and characteristics of tropical humid areas. And these are the characteristics. 1, heavy and reliable rainfall exceeding 1,200 millimeters per annum. It means when you add the rainfall totals, January, February, March, April to December, they exceed that amount. Sometimes go beyond 1,500 millimeters. That's one characteristic. Another characteristic of tropical humid areas, whenever they ask what are tropical humid areas, these are places that are characterized by the following. Rainfall throughout the year. These areas experience rainfall throughout the year with no distinct dry season. So it rains throughout the year. Even if some months receive low rainfall, but it's there. Then the areas are also characterized by hot temperatures of average 24 degrees Celsius. Then another characteristic, small diurnal range. The word diurnal range means daily range of temperatures. For example, during the day, if the hottest temperature was 24 degrees Celsius, the lowest can be 21. So 24 minus 21, that is 3. Or 24 minus 22, that is 2. So it ranges between 2 to 3 degrees Celsius. That is the temperature range. That is diurnal range. It is small. These areas are also characterized by high humidity of above 80%. Humidity means the amount of water vapor in the atmosphere. So when an area receives heavy rainfall, the humidity is high because the amount of water vapor in the atmosphere is high. So these areas are characterized by high humidity of above 80%. They are also characterized by dense cloudy cover. Unlike in semi-arid areas where the cloudy cover is very limited, but tropical humid areas, there is cloudy cover. That's why the diurnal range, the daily range is small. Okay. Then after identifying characteristics, okay, you now briefly describe chemical weathering processes. That's why I say the chemical weathering processes include oxidation, hydrolysis, carbonation, hydration, solution, reduction, and chelation. Now, these processes we are not going in this question, you don't over-explain them. You just highlight briefly, like I've started doing for you. You just say oxidation, this is the first one, is the reaction of oxygen and mineral components in the rock. For example, iron and aluminium. It means if a rock has mineral components like iron, aluminium, these mineral components react with the oxygen, okay? And this is facilitated by water and hot temperatures. So when these mineral components react with the oxygen, it means there's going to be a change in the chemical nature of the rock. And we say that process of chemical weathering is called oxidation. It's derived from the word oxygen. It's the process whereby oxygen is added to the mineral components of the rock, like iron and aluminium, changing basically the color of the rock, sometimes to reddish brown. That is oxidation. That's enough brief description of oxidation. Then we are going to write briefly other processes and then explain them. I think let me clear this and we briefly write about these chemical weathering processes. Let me clear this part. Clear this part. Learn briefly, note down something, and at the same time, listen to the explanations, and then we can get to them. Okay. That is oxidation. Then you can say hydrolysis is the reaction of hydrogen. Say hydrolysis is, but this is the brief description of this chemical process. Brief description is chemical weathering processes. Hydrolysis is the reaction of hydrogen ions, is the reaction of hydrogen ions in water and feldspar. Water and feldspar produce potassium hydroxide. Use potassium hydroxide and aminoacidic acid. Acid and aminoacidic acid. So that is hydrolysis. In this hydrolysis, if I may explain briefly, we have that rock. That rock has amine rock. Part, this part. This is a rock. So we are saying hydrolysis is the reaction of hydrogen ions, water. So the hydrogen ions in water, assuming this is water. So the hydrogen ions in water will come and penetrate, get into contact with a rock containing this mineral feldspar. Okay? And when hydrogen ions in water, of course, when it changes, they are hydrogen ions in water, which penetrate a rock containing feldspar. And this feldspar will break down. That's when water containing hydrogen ions are attacking this mineral of the igneous rock. Feldspar is a mineral in the igneous rock. So the feldspar will break down after being attacked by hydrogen ions in water. It will break down to produce potassium hydroxide and aminoacidic acid, which further decomposes to form minerals. So in short, hydrolysis is the process through which feldspar breaks down to produce clay minerals. The hydrogen ions in water get in contact with a certain mineral in the rock known as feldspar, which is going to break down to form clay minerals. Some students find it hard to say feldspar breaks down to produce potassium hydroxide and aminoacidic acid, which aminoacidic acid further decomposes into clay minerals. The shortcut is this one breaks down to form clay. So we say that process is called hydrolysis. So hydrolysis process associated with a certain mineral of the igneous rock known as feldspar. That is hydrolysis. The first one was oxidation. The second is hydrolysis. Then the third is carbonation. Yes. 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 Hand, I can say hand. Yes.
Teacher, teacher, I was asking the meaning for that word feldspar.
It's a mineral. It's a mineral in of the igneous rock. Rocks have minerals. So that is a mineral component of the rock. Okay.
Okay, thank you.
Have aluminium, iron in other rocks. Okay. So that is the rock which is attacked by the hydrogen ions in water to break down and form clay. That clear?
Yes, teacher.
Okay. And we continue with the carbonation.
Yes, teacher.
Okay. Carbonation comes from the word carbon dioxide. So carbonation, let us first briefly write it down, then I'll explain it. Carbonation involves rainwater, which dissolve carbon dioxide, which dissolve carbon dioxide. I've just written that because I've just written the symbol, but we write carbon dioxide, which dissolve carbon dioxide, produce carbonic acid, produce carbonic acid, which react with calcium carbonate, form new compounds. That is the brief description of carbonation. It involves rainwater, which dissolve. Which dissolve carbon dioxide in the atmosphere, produce carbonic acid. And this carbonic acid reacts with calcium carbonate, form new compounds. Let me explain to you this one so that you understand it. You see, when you are answering questions connected, whether these processes are important because they must be integrated. We did yesterday how we are integrating physical weathering processes. Now, carbonation, this is how it happens. We have this. This is a rock. Rocks have minerals. Assuming this is a rock and has a calcium carbonate. Limestone rocks have minerals like calcium carbonate. So what happens when it rains? That rainwater will dissolve some gases in the atmosphere, and in the atmosphere the gases carbon dioxide. So rainwater will dissolve carbon dioxide to form carbonic acid. Opposite chemistry know this better, that when water combines with carbon dioxide in the atmosphere, it forms a weak carbonic acid. And that weak carbonic acid will get into contact with a rock containing calcium carbonate. So it is dissolved. So this is the carbonic acid which is dissolving calcium carbonate in the limestone rock. To form new compounds, that's where it goes. To form new compounds. But what is this new compound? When carbonic acid penetrates a rock containing calcium carbonate, it breaks down to form calcium bicarbonate. That is a new compound, or calcium hydrogen carbonate. But because we are just looking at brief description of these chemical weathering processes, we are saying carbonation involves rainwater. This rainwater dissolving carbon dioxide in the atmosphere to produce carbonic acid, which carbonic acid reacts with calcium carbonate mineral in the igneous rock to form new compound, and that is already chemical weathering. Because new compounds have been formed, they have been formed. Why? Because carbon dioxide dissolved, water dissolved the carbon dioxide to produce a weak carbonic acid, which carbonic acid is now attacking a rock containing calcium carbonate to produce new compounds. So any rock containing calcium carbonate is weathered through the process of carbonation. Any rock containing feldspar is weathered through the process of hydrolysis. Okay. Any rock that comes into contact with oxygen is weathered through the process of oxidation. So that is carbonation. Then another chemical weathering process, briefly looking at them, oxidation, where we say oxygen added to the rock. Hydrolysis, where we say hydrogen ions and water are attacking the rock containing feldspar, which breaks down to form clay. Then we are saying carbonation by saying water combining with carbon dioxide in the atmosphere, forming carbonic acid, which gets into contact with the rock containing calcium carbonate to produce new compounds. Which are these new compounds? To produce calcium bicarbonate, like in Tororo, like in Nyakasura. Then we say hydration. And this hydration, the process where certain minerals is the process where certain minerals in the rock absorb water. Rock absorb water and expand, causing internal stress. That is it. Hydration. Have this as a problem. And of course, this rock has minerals. Most of the rocks have minerals. So, what is hydration process? The process where certain minerals in the rock absorb water, causing internal stress. So, when water penetrates this rock containing some minerals, it will cause internal stress. Certain minerals in the rock absorb water and expand. So these minerals, after absorbing water, expand, and this causes internal stress in the rock. And when it causes internal stress, there is no great chemical change in the nature of the rock, but the rock bonds are weakened. Okay, the rock bonds are weakened. So hydration process involves addition of water in the rock, causing internal stress. Okay, and leading to expansion of the rock, resulting into weakening of the rock bonds. That is hydration process. Then there's another process called solution. Solution, like the word suggests, solution involves dissolving minerals. Solution involves dissolving mineral components, dissolving mineral components, dissolving mineral components which are carried in solution form, which are carried in solution, which are carried in solution. For example, rock salt. That process is called solution. It's a process whereby water dissolves mineral components in the rock, and these minerals are dissolved and carried in solution form. So the process is common in areas that have rocks that are soluble in water. And we are giving an example of rock salt. Okay, and calcium. Calcium can also be easily dissolved in water. So the difference between solution and hydration: for hydration, water penetrates, water is absorbed. Okay, certain minerals absorb water and expand and cause internal stress of the rock, resulting into weakening of rock bonds. But solution involves dissolving mineral components which are currently in solution form, common in areas that have soluble rocks, like limestone rocks, like rock salt. So that is solution. Then let me clear this part and write another process, which is reduction. Reduction occurs in swamp areas which involve occurs in swampy areas which involve removal of oxygen, which involve removal of oxygen, from the rock, and addition of hydrogen ions. Addition of hydrogen ions. Okay, that reacts with rock to cause new compounds. That react with the rock cause or produce new compounds or form new compounds. As we said, oxidation involves addition. Of oxygen to the mineral components of the rock. Reduction is the opposite of oxidation. Because we are saying it occurs in swampy areas. It involves removal of oxygen. Oxidation is addition. Reduction is removal of oxygen. Okay, it involves the removal of oxygen from the rock. Now, when oxygen is removed from the rock, instead hydrogen ions are added. Okay, and these hydrogen ions react with rock to form new compounds. The moment oxygen is removed and hydrogen ions are added, then there is a reaction to form new compounds, and that's already chemical weathering process. That is what we mean by reduction. And lastly, chelation. Chelation involves addition of mineral components, to that rock through plant roots or addition or chelation involves addition of mineral components to the rock through the plant roots or removal of nutrients, removal from the rock through the same roots. Didn't change in the nature of the rock. Change in nature of the rock. Stop. So that is chelation. Chelation process is common in densely vegetated areas, areas with dense vegetation. Here, these plants have roots. So these roots can extract mineral components from the rock and sometimes add mineral components to the rock through the same roots. So in this process, the rock changes its composition. So chelation may involve addition or removal of mineral nutrients by use of plant roots. That's why it is common in densely vegetated areas. So those are the chemical weathering processes. We have looked at oxidation, addition of oxygen, hydrolysis, decomposition of feldspar, okay, to produce clear minerals. Hydration, okay, the rock absorbs water and it causes internal stress, resulting in creating the rock bones. Solution, mineral components of the rock in the rock are dissolved and carried in solution form, for example, rock salt. Reduction, removal of oxygen, and addition of hydrogen ions. Then chelation, involving plant roots extracting and adding minerals to the rock. Those are the chemical weathering processes. Remember, the question accounts for the dominance of chemical weathering in the tropical humid areas of East Africa. For those who have just obtained us, the question was account for the dominance of chemical weathering in the tropical humid area of East Africa. Tropical humid areas of East Africa. And we started by saying we define chemical weathering, which we have done. We identified tropical humid areas and their characteristics, which we did. Then after that, we highlight or briefly describe the chemical weathering processes in these tropical humid areas, which we've just done. Then from there, we are looking at factors to account for the dominance of chemical weathering processes. And these are the factors that I'm going to explain to you. But now when we are explaining factors, as I've said, and you are explaining a factor like rainfall, that the occurrence of chemical weathering is due to heavy rainfall, you see, and you say heavy rainfall provides water, okay, that reacts with mineral components in the rock, okay, resulting into chemical weathering processes, right? Carbonation, hydration, solution. So you are integrating, not saying the presence of heavy rainfall in areas has resulted into water dissolved in minerals, resulting into chemical weather, and leave it general like that, resulting into which kind of chemical weather. Okay. Then when you say hot temperatures in tropical humid areas accelerate the rate of chemical reactions, okay, and this has resulted in chemical weathering process like hydration, hydrolysis, carbonation. When you come to nature of parent rock, you are going to say parent rocks that contain minerals like calcium carbonate are easily dissolved okay, resulting into chemical weathering process like what? Carbonation, when you are talking about rocks containing minerals like feldspar, they can easily be weathered through the process of hydrolysis, like we are going to give. Okay. Before we give factors for the dominance of chemical weathering, is there any question? Any question? So these factors, I'm just going to write them down on the blackboard, then we explain them so that you can follow. Okay. Let's make clear this blackboard so that we can write the factors and know how to explain. Okay. The factors. Let me clear the board so that you can have a clear view. Okay. Dominance of chemical weathering due to the following factors. Name it. I'm writing points so that I can explain. Okay, let me first explain. Listen carefully. Now these factors. There are quite a number of factors. I first want to explain the dominance of chemical areas is a result of heavy rainfall. Here you say heavy rainfall in the tropical humid areas exceeding 1,500 millimeters provide water, okay, that dissolves mineral components in the rock, leading to chemical weathering processes like carbonation, oxidation, hydration, hydrolysis in areas around Lake Victoria Basin. So how you get to that point? We have not said heavy rainfall like water as chemical weathering. We are saying heavy rainfall areas that exceed 1,500 millimeters provide water that dissolves mineral components in the rock, okay, resulting into chemical weathering processes, like which chemical weathering processes mentioned in carbonation, hydration, hydrolysis, solution areas around Lake Victoria. That's one. Heavy rainfall is providing water. Two, in tropical humid areas, there are hot temperatures. And what's the use of these hot temperatures? Hot temperatures in tropical humid areas accelerate the rate of chemical reactions. And this has led to chemical weathering processes, right? Hydrolysis, hydration, oxidation, carbonation. That is hot temperature. So, in as far as climate is concerned, we are not looking at hot temperature that resulting into expansion and contraction, but we are saying hot temperatures accelerate the rate of chemical reactions, leading to chemical weathering processes, right? Carbonation, oxidation, hydrolysis, and hydration. Then we may say another factor in tropical humid areas, the nature of the parent rock accounts for the type of chemical weathering. The nature of parent rock. When we say parent rock, we can consider mineral composition of the rock. We can consider jointed rocks. We can consider permeable rocks. We can begin with jointed rocks because before we come to the composition, say in tropical areas, jointed rocks, okay, allow percolation of water. Water uses joints to penetrate the internal structures of the rock, dissolving minerals, okay, leading to chemical weathering process like carbonation. For example, limestone rocks are jointed. You see that? Jointed rocks allow percolation of water because water uses joints to penetrate the internal structure, dissolving minerals, leading to chemical weathering processes like carbonation, oxidation. I'm not saying leading to chemical weathering, but I am interpreting processes. The same applies to permeable rocks. And say permeable rocks, like limestone rocks, permeable rocks are those which allow water to percolate through them. So you say permeable rocks allow easy percolation of water, which dissolves mineral components, resulting into chemical weathering processes like solution, like hydration, like carbonation. That is permeable rocks. Then from there, we can go to mineral composition of the rock. And say rocks containing feldspar minerals are easily dissolved, leading to chemical weathering process like hydrolysis. Feldspar hydrolysis. Never feldspar. When I say okay, water containing hydrogen atoms, feldspar, which breaks down to produce potassium hydroxide and aminobutyric acid, which further decomposes into clay. So you can just say rocks containing feldspar can easily be weathered through the process of hydrolysis. That is when feldspar breaks down into clay minerals. Then you say those which contain calcium carbonate, like the limestone rock, can easily be weathered through the process of carbonation. I'm not saying calcium carbonate, rocks containing calcium carbonate are easily weathered chemically. I'm saying through the process of carbonation. Then those which contain, which have ammonia can easily be weathered through oxidation process. Through oxidation process. While soluble rocks, like rock salt, can easily be dissolved through the process of solution. There have exhausted nature of the parent rock. One, climate, we looked at. Nature of parent rock, we looked at. Joints, permeability, mineral composition. And mineral composition, we can give an example that some rocks have feldspar, others calcium carbonate, others iron and aluminum, while others are soluble. So they can be weathered chemically through different processes, like soluble rocks through solution, iron and aluminum bearing rocks through oxidation. Rocks with calcium carbonate, like limestone rocks, through the process of carbonation, and those ones with feldspar through the process of hydrolysis. Those are two factors. Then we shall look at the third factor as relief. Let me write relief. I have some students written down this for sake of revision. Yes, we can now proceed to the third factor, which is relief. Relief. We can look at now relief. Okay. Okay, relief. That's number 3, relief. Chemical weathering. In tropical humid areas, it's due to presence of gentle slopes and low-lying areas. Presence of gentle slopes and low-lying areas. Okay. These allow accumulation and percolation. Accumulation and accumulation and percolation. Accumulation and percolation of water to chemically weather the rock. Chemically weather the rock through processes like carbonation, hydrolysis, and others. That is relief. You see, another factor to account for the dominance of chemical weathering is the presence of gently sloping landscape and low relief. Okay, gentle slopes and low-lying areas. These areas allow accumulation and percolation of water into the internal structures of the rock to chemically weather the rock through processes of carbonation, of hydration, of solution. Then we can even add that in tropical humid areas, the steep slopes allow excessive runoff, exposing the parent rock agents of chemical weathering water. So when the parent rock is exposed, water can penetrate and chemically weather the rock. That is relief as the third factor. Third factor is relief. Then we can look at the fourth as living organisms. Write it here. Living organisms. These ones also account for the dominance of chemical weathering. Living organisms, right? Man, two, vegetation, and three, other living organisms. We'll move this. Okay. Man. Looking at how man, we shall look at emission of industrial gases, that is one. Dumping, that's the second. Mining and quarrying, and then irrigation. So, living organisms, including man, including vegetation, then other living organisms. Here, we are saying man, through emission of industrial gases in the atmosphere, increases acidity of rain, and this has accelerated chemical weathering process like carbonation. And through dumping, okay, of industrial, domestic, and agricultural effluents on land and in water, it also increases acidity of the environment. And when there is increase in the acidity of the environment, that is accelerating the rate of chemical weathering through the processes of carbonation. That is man. Emission of industrial gases, dumping, okay, land. Then through mining and quarrying, when man is going to carry out mining, he clears vegetation. And vegetation is important in protecting the parent rock from penetration, excessive penetration of water. So in the process of man trying to carry out mining and quarrying, he clears vegetation first and exposes the rock to water. And at the same time, he uses explosives in mining and breaks the rock physically. And when the rock is broken down physically, it means cracks have been formed where water can penetrate, get into contact with minerals in the rock, and dissolving these minerals, leading to chemical processes like hydration, like solution. Then man can also add water to the soil through irrigation. So in the process of carrying out irrigation, is adding water to the rock, and in the process that water dissolves minerals, accelerating the chemical processes of solution, carbonation, hydration. So man plays a big role in contributing to occurrence of chemical weathering in these tropical humid areas. You have seen the activities: emission of gases, dumping, mining, quarrying, and irrigation. think that is man. Then we come to vegetation. Now, when there's vegetation in an area, those leaves you see of plants can decompose. They fall on the ground and decompose and form humus. Decompose and form humus. Now, when water is added to that humus, humic acid is formed, and this is crucial, important in the chemical decomposition of the rock. Okay. Then, again, for vegetation, plant roots release minerals to the rock and sometimes extract minerals from the rock. And this has accelerated the process of chelation, which I talked about. Accelerate the process of chelation. So when you have new plants, animals, many plants rather, their roots can extract and at the same time add minerals, chemically weathering the rock through the process of chelation. Okay. Then other living organisms secrete acids that chemically decompose the rock. Okay. For example, uric acid can decompose rocks. So this is a result of some living organisms like bacteria. They can secrete solutions or secrete acids that can decompose and chemically weather the rock. Then we can say the holes dug by burrowing animals like moles, termites. These holes are avenues for water percolation. So the rodents dig holes underground and break the rock physically, but water can use or percolate the internal structure of the rock through these tunnels that have been created by these animals. And this can lead to chemical weathering. Okay. You know, so living organisms, man, vegetation, other living organisms. So the factors: climate, relief, nature of parent rock, living organisms. Okay. Then there is drainage. Okay. That poorly drained areas like floodplains, chemical weathering is dominant. Okay. Drainage. Poorly drained areas like in floodplains, chemical weathering is dominant in the form of hydrolysis, hydration, reduction, which help to decompose the rock. And then we can say the last one is time. Chemical weathering is a slow and very long process which needs sufficient time. So short period of time does not encourage any form of weathering, but the longer time taken for the rock to be exposed to weathering processes, the more effective the weathering is. So chemical weathering is due to the sufficient amount of time that is given to the weathering process, to the weathering agents act on the parent rock. So the longer the time, the more effective the weathering process is. In summary, chemical weathering is dominant in tropical humid areas because of climate, relief, parent rock, living organisms, and look at living organisms at man, vegetation, animals, drainage, time. Those are the factors account for the dominance of chemical weathering in the tropical humid areas of East Africa. We can now see that when we looked at climate, we considered rainfall and temperature. When we looked at relief, we considered gently sloping and low relief, and then steep slope exposing the parent rock to agents of weathering. Then we looked at parent rock, and for parent rock, we looked at mineral composition, we looked at permeability, we looked at jointing, and we categorized them. Then living organisms, we looked at man and the different forms, how it has contributed to chemical weathering. We looked at vegetation, we looked at other living organisms like bacteria, the rodents, the termites. Then we looked at the drainage and the time. In all, in summary, those factors account for the dominance of chemical weathering in the tropical humid areas of East Africa. That is how we try to approach that question. Let me give you a short break, and then in case you have any question, you can ask before you see what to do. Any question, any comment, any.
Yes, sir. I have a question. Hello? Sir, I have a question. I have a question, sir. What I'm saying. Hello?
Hello?
Yes, what I'm saying, sir.
Yeah.
When answering on the part of the factors after drawing a transitional paragraph, do we point climate and then talk about rainfall and temperature, and then go on living organism, and then go on relief, or we just go direct, talk about rainfall, talk about climate, and like that direct?
Yeah, now when you are writing an essay, don't put subheadings, okay? Just use paragraphs. Okay? We just begin a paragraph. The dominance of physical weather and chemical weather in tropical is because of the presence of heavy rainfall, okay?
Yes.
Which extends okay? Which provides water, okay? That source minerals in the resulting into chemical weathering process, right? Full stop, okay? Then another paragraph, the hot temperatures. Another paragraph, you just go, the hot temperatures in tropical humid areas accelerate the rate of chemical reactions, just like that. Don't write a subheading. Yeah.
Okay, thank you, sir.
You just
we are together.
Okay. Yeah.
Okay, thank you, sir.
Any other? Any other? Remember, students, when you are writing your answer, don't write them like drainage under any time. No, here I'm doing this for you to understand better, to point out the clear points. But for you, write paragraph your work, short paragraphs and explanation. Don't say climate, then you underline them. Or living organisms. Yeah, the dominance is a result of this. The hot temperatures does this. Nature of the parent rock in terms of permeability, joints, mineral composition, okay, account for dominance of chemical weathering. Permeable rocks like limestone allow percolation. That is how you write just in paragraph 4. Okay, any other? Yes. Anita.
Okay, teacher, thank you. Yeah. But I'm like, when I'm attempting that question and I feel I want on the step of bringing out the processes, what if I just outline and I leave explaining? Can I be penalized?
No, when you just mentioned the chemical weathering processes, hydration, hydrolysis, like that.
Yes.
Now you see, this is a mark by impression. If you want to just highlight them, okay, you can't be penalized, but you cannot score like someone who has highlighted briefly, because the one who has highlighted is demonstrating a sense of maturity. He knows what oxidation. You don't need to explain the details, chemical weathering processes, because the question is not about chemical weathering processes. Details like writing equations and what, no. Just highlight, like I've just been giving you. Oxidation involves the addition of oxygen to mineral components in the rock. Carbonation, which is just short 2-3 lines, 2-3 lines.
Okay, thank you, sir.
Yeah. Okay. Any other? Okay. Now, members, any other? Someone putting up the question, Mister? Any other person putting up the question?
No. Any other question?
No. Now, when you get that kind of question, and in this case,
I'm seeing change.
yes, before we go to another what?
Tendo.
Tendo. Tendo. Tendo. Yes.
Yes.
Okay. Now, I want to give you a challenge to the learners. Having looked at that, we have started with account for the dominance of chemical weathering in tropical humid areas. Now, suppose they give you this. It is going to be like that question we just discussed, but this time we are changing it. To what extent does nature of parent rock, does nature parent rock influence chemical weathering? Influence. To what extent does nature of parent rock influence chemical weathering? Chemical weathering in the tropical humid areas of East Africa. Now, you see, learners, when we teach you questioning approach, you may not necessarily get exact question, but we try to teach you how to think and really interpret the questions on your own. Having taught those two questions, account for the dominance of physical weathering in semi-arid areas yesterday, and today account for the dominance of chemical weathering in the tropical humid areas of East Africa. Now, suppose you come across that challenge. I've discussed chemical weathering processes, I've discussed tropical humid areas and so on. Now, if you get a challenge, to what extent does nature of parent rock influence chemical weathering in the tropical humid areas of East Africa? Can anyone try to, can you be in position to interpret that now? Who can try it? And we see if you have an idea, assuming you have come across that challenge, you are alone, but they want you to interpret that one. But you have an interpretation of the one we have just done. Can you fail to interpret that one? So who can try it? You can put up your hand. Just try the approach.
So let me try.
Oh, thank you.
First of all, you first defined what chemical weathering is.
Definition of chemical weathering, right?
Yes. Then after you defined what a rock is.
Define a rock.
Yeah. Yes.
Let me first see your appropriate react. Yes.
Then after defining what a rock is, you first identify the tropical humid areas.
Tropical humid areas, good.
Then after defining the tropical
Yeah. After defining tropical humid areas. Oh. Network. Not getting you. I've lost you. Network. She was trying to interpret for me this question, and she was coming up with something good. Grace. Yeah, we have lost the other one. She was trying it out, but we've lost her. Okay. Grace.
Yes, teacher.
Yes.
For me, I would say we first define chemical weathering.
Good.
As she said, we give examples of the tropical humid areas. We
Very
give
good.
the characteristics of the chemical weathering.
Very good.
Then the processes of chemical weathering. Then we go to nature of the parent rock. Since the question is talking about nature of the parent rock, we talk about the nature of the parent rock in the mineral composition, jointed and permeable. Then we say, then we continue and we say, however, other factors are responsible for chemical weathering in tropical humid areas. Thank you.
What's your name? What's your name? Hello? Grace. Grace? Yeah, Grace.
Yes, teacher.
You are Grace. Yeah, thank you
Yes,
very much.
teacher.
That is exactly the approach. Okay? It means you have been following keenly. Thank you very much for that interpretation. You are 100% right. Correct.
I'm sorry, I went off. My network is not clear enough.
Yeah, I'm saying that is exactly,
yes, please.
That is exactly how you are supposed to approach it. Thank you very much. It means you have been following keenly. Okay? Yeah. You borrow the information you have been discussing to interpret this question by defining the chemical weathering. Like you say, defining chemical weathering, identifying tropical humid areas and their characteristics. Then after that, the chemical weathering processes. Then after identifying chemical weathering processes, you go now to nature of the parent rock, how it accounts for, how it influences chemical weathering in tropical humid areas. Nature of parent rock, you go to permeability, jointing, mineral composition. Okay. Then after that, you say, however, okay, there are other factors that influence chemical weathering in tropical humid areas apart from nature of the parent rock. Then when you go to other factors, you bring in climate, you bring in living organisms, you bring in time, you bring in relief. In other words, in this question I've just given, you begin the approach as we started in the beginning. Then when you are going to factors, you begin with parent rock. You show extent, you can say, is it to a great extent or a less extent? Okay, you can say to a less extent, nature of parent rock has influenced chemical weathering. Then you go to permeability, joints, mineral composition, you explain. Then after that, you say, however, there are other factors apart from nature of parent rock. Then other factors, climate, time, living organisms, relief, drainage. Then you make an evaluation. Okay. Of course, this is to a small extent. Okay. To a large extent, it is climate that influences chemical weathering in tropical humid areas, although nature of parent rock also contributes. So thank you very much for interpreting that question. means you have been following, and you can even interpret others. When you get interpretation in 2-3 questions, you can interpret other questions as long as you get used to the format of how you move around. You move when you're answering that question. So learners, I think we can stop here today. Like I said, when we get time still, we shall come back and interpret some other questions. At least I know for weathering, some people can really try to interpret, okay? As long as you are focused and following keenly. Okay? I don't know whether I can leave you with this. To what extent does nature of parent rock determine the rate and character of weathering in East Africa? That is question 4. Question 4. Discussion. When you come next time, you can try to interpret it on your own. When I come next time, you can first tell me, I did this, then you can go on and explain it. To what extent does nature of parent rock determine the rate and character of weathering in East Africa? This time they are not saying either chemical, physical. To what extent does the rate and character of weathering? To what extent does nature of parent rock determine the rate and character of weathering in East Africa, general weathering in East Africa? You try out that. I don't know if you try it out, how it can mark you. Some people who wish to try out that.
So can we inbox you through WhatsApp?
Yes, that's like, you have my number in WhatsApp. You can try it, then I can mark you. And when we come next time, we can try to correct some few mistakes. They are there. And if you have interpreted it right, that's very good.
Thank you,
Yeah.
sir.
Yeah, but after